In this video, we're going to be taking a look at multi-environment customized workflows. So in the previous video, you saw the different day 1, day 2, or day 3 ops we're going to be taking a look at. So right now in this 6 multi-environment directory, you'll see we have a base in there. Now if you take a look at the base, it's just pure manifest files with deployments and service to deploy the online boutique sample application that we're going to be using for this section of the course. And we have a customization file in there that just ties in all the various resources together. Let's try to run the application and see what the application really does. So right now I'm just going to navigate into the base directory, copy path, paste, and I'm just going to do a kubectl apply k in that directory. Now what I expect is it's going to create our Kubernetes deployment, and we just want to see what the deployment is like or what our application is like, service pods, and I'm just going to do an output wide here. Okay, so you can see it's creating all our Kubernetes resources, services are created, pods are created, and our front-end application should be running on port 3070, as you can see here from the external facing services. So I'm just going to forward that port and let's see what the application is like. Okay, port forward, service, front-end external, and want to forward the port 30,073 to the port 80 in the container. Okay, to the service port 80. Okay, so now let's take a look at that port in our browser and see what our application is like. So we're just gonna go back to our browser, paste in that URL, just gonna call this localhost. And if our application is up and running already, yes, you can see we have our application. So I have I'm just gonna turn off my dark mode reader. Okay, so you can see we have our application running. Just a basic online shopping cart. You can click through, add items to your cart, change the quantities, and you can place order for items. So that's basically the use case for the application, and you have a nice cart here if you want to go back to your cart. Okay, so now we have the application running. Just gonna kill that back. Now I want to take a look at how we can begin to transform this sample application that we have into a multi-environment workflow. So first off, I'm just going to delete everything we've deployed since we really don't need it, right? Okay, so while that's clearing out, okay, now from our base customization file here, or from our base manifest resources that we have here, one of the first things you notice is we have this environment variables for stats, disable tracing, and the disable debug environment variables. They're common to almost every manifest we have in here, and that's because the online boutique application supports the ability to enable or disable tracing for Google Cloud Ops. If you're running this in Google Cloud infrastructure, then you can enable or disable Google Cloud tracing, Google Cloud monitoring, and debugging. Okay, so now if I go into one of my overlays I have in here, which is the first overlays, think about this as day 1, in which you're transforming this manifest into a customized workflow. So here I have a day 1 and I have a dev, prod, and stage environment. Now if I take a look at the dev environment, in there I have a customization file, and all it does is just accumulate all the resources from base, just like we had done initially. And then we're also creating a dev namespace, which we're doing here in this overlay, and then we're deploying all those resources to a dev namespace. Now if you remember, Kustomize is smart enough to know that the namespace resource needs to be created first, and so if we just do a Kustomize build in that directory, we can see what's gonna happen. Okay, and this is the most basic use case, right? Kubectl customize, just the customize in that directory. Now this is the most basic use case for multi-environment, where you have this for your dev, and for our stage we have a very similar use case as well, where we just have our namespace created, we have our base resources, but then let's say we just want to tag on or increase the number of replicas for our front-end deployment to 2, for example. While in production, let's say we want to increase the number of our front-end deployments to 3 to take on more traffic. So this is one very simple use case. If you have a simple monolithic application, this can work really fine. Just going to tag this onto results.yml file just so we can easily navigate the content of that file. Okay, so you can see namespace created and all the other resources are created. And we're just going to apply this and see if that works. kubectl apply k dot. Now that should create the namespace just like we expected, create all the resources for us as well. We're just gonna do kubectl config set context, current context, and set the namespace to the dev, so we don't have to type in the namespace every time. Now I can do kubectl get service pods, and I'll just do output wide again so we can get the port at which our external service for the front end is running on, and now it's running on port 30,434. So we need to forward the ports in which our application is running. So let's do a kubectl port forward the service front end external. We're forwarding port 30434 to port 80 again in our container, just like we did before. And now if we do a refresh, we should have our application running. Okay, so we have our application running again. This time around, we can click through just to confirm that everything is working as expected. Okay, you can see our application is running and everything is working. Awesome. Fine and good. So this is a basic use case for simple monolith or simple microservice application. Now this worked fine and good for us, but in the event that we want to go a step further, right, to improve what we have so far, this has so many duplications and can become a pain to manage. And if you remember, in one of the exercises in the previous video is to see what are the challenges that can arise from running this on its own, right? And some of the challenges we see, first of all, is the duplication of so many environment variables that do the same thing across most of our manifest files, right? Most of our manifest files have this disable profiler, tracing, and stats, and that's used to enable or disable Google profiler, start up tracing, and debugger. Okay, so we can extract out that functionality from what we know so far into something like a component. Okay, and then we can enable or disable it as the need arises. And we can automatically apply that in our overlay, because this for the behavior whereby if we want to disable or enable tracing for a particular environment, we'll have to override what's already set in here, okay, which can begin to become an additional level of complexity for us to manage. Okay, so in here I've done something. This is day one. In what we have as day two in here, I've extracted some of these functionalities into different components, and just to kind of give you an idea of one way we can approach optimizing this manifest into something that will be really useful and flexible and convenient for our team to work with in the long. So first of all, let's just delete what we have in here since we don't need those resources anymore. For now, we show application run, and for prod and stage environment for day one, it's the same thing. We can build that and run, and application works fine and good with just very basic overlays. But in day two, let's see what our dev environment looks like. So if I go to dev, customization, the YAML file, interesting. Now we have several other changes in here. Now we're reading from something I call a base 2. We're still creating the namespace, but then now we have so many components in here. Okay, now let's take a look at this for a moment. Let's see what our base 2 base manifest are. So this is the same as what we have in our base one, but then with a couple of changes. The first change you'll notice here is I have a new component now for Google Cloud Ops, and if you take a look at what that component is like, it's just a customization component file with a patch that's patching all resources, okay, that has the name deployment in it, and using the patch that adds the disable debugger, profiler, tracing, and stats environment variable into the container. Okay, so we're saying all our deployments. Now the name field for patches is a regular expression. Okay, so in most examples you see, you may not see all of this, you may just see the name, but it's an inherent regular expression applied to that field. So here I'm saying any deployment name that matches or has the substring deployment in it, then apply all these environment variables in there. Okay, now this makes this functionality reusable, because if we do not want to enable, or we want to enable Google Cloud tracing and profiling in any of our environments, we can easily do that in our overlay by just not including this component. And how do you know that? Because in our base2 manifest here, we have extracted out those environment variables. So if you take a look at the manifest in here, you'll see that we no longer have those environment variables for the disable or enable Google Cloud tracing as we had earlier. Okay, now our manifests are all free of that change. So this is one step further to cleaning out the manifest environment files that we have, and it gives us the additional ability to customize the overlays in which we want to enable Google Cloud monitoring and statistics. Something else we've done in here is, if we look at the customization file again, is security context. If you take a look at our base, our standard base, we had the security context on all of the containers or all of the pods. We have the security context that sets the group, the pod should run as non-root, all these additional security configurations. This is common to almost every microservice we have in here. Okay, that configuration is duplicated across all of them. Now that means if we want to change this for any reason, we're going to have to change it in 11 or 12 different places, which can become a hell to manage, right? So something I've done here as well is to extract the security context out into a component. And now we have a component here that matches all deployments again, just like we had before, and attaches the security context in here. Now note here we're using inline, just like we've done in the past. You know, anything you can do inline, usually in Kustomize, you can also do with a configuration file. So I can decide to just pass in the path to a configuration file here. But here I'm saying match all deployments and append the security context to the deployment. Okay. So now we can optionally enable or disable the security context configuration for any overlays, just like we desire. Now this makes our manifest cleaner, first of all. But what it also does is makes it super easy for us to update our security context across all the pods that are running in an overlay environment, which is awesome, or nothing short of amazing to have if you make a lot of frequent changes to your Kubernetes manifest. Now let's look at another optimization we've done in here, and that's for the resource groups. Now resource limits and requests are how you control resource allocation in Kubernetes for pods and containers. Okay, so if you take a look at all deployments in here, the containers have resource specifications, and most of the resources for all the different microservices here can be grouped into 4 different categories. So what I've done here out of my own free will is to go through all of these deployments and take out the resource limits and group them into 4 different categories. So what I've done here is to create 4 different components, and for each of these components I have something I call a resource group. So I'm setting a label on the deployments that tells me which resource group I want to associate with that deployment. If you tag a deployment with a resource group A, they automatically have this resource configuration. Now think about this as a final way to manage requests and limits for all your containers. And this becomes really useful if you have a really large number of containers to manage. You can easily manage the resource limits and requests of your containers using labels. So if you take a look at the deployment files in here, I've added labels. Now this labels tells me what resource group I want to associate with this deployment. If you scroll down a bit, you'll see we no longer have the resources field in our base manifest, and that's because I don't want to be stuck to those limitations. Now in the dev environment, for example, I'm adding those resource groups, resource group A, B, C, and D. And all the component here is doing, this label selector is saying if the resource group of the deployment is resource group A, then append this resource limiting request to the containers. Okay, and that's similar for resource group B as well, and resource group C, and all the other resources. So you can see the resource limits and request changes based on the resource group that's attached. So this gives us a final way to control the request and limits using Kustomize. I can keep going on and on and on. There's a lot of changes that can be done, but I'll leave the rest for you as an exercise to work on. And if you look at the front end deployment, you see we still have a lot of Kubernetes environment variables here in this deployment. So something you can do is extract this out into like an env file and then attach that to the deployment. Okay, so let's see if our day 2 optimizations work as we expect. So in our dev environment now, we're including the resource groups, security context, and our Google Cloud Ops. And if we copy that, paste it, and we do a Kustomize, let's do a Kustomize build and see what that gives us. Okay, now if we take a look at what our dev resources gives us, yep, nice namespace created, all the services are getting created. But if we take a look at our deployment, the first deployment we have here is the add service. You can see it has a resource label of resource group C. So what we expect then is that the resource limits that will be attached to this pod should be the resource from a resource group C. And you can see here we have resources for request for resource group C, and you can confirm that by going in here and checking what's in resource group C, clicking on it, and you can see those are the resource limitations that we have for resource group C. So 200 milli-CPUs and 180 megabytes. Okay, so if I go back to request, then you can see request is set and limit as well is set correctly. Okay, so next, security context. This is security context for the container itself. We're not updating that. What we're updating is security context for the pod, and that's where this comes in. You can see that's getting added correctly because the path we're adding is the paths to the spec and not the container in itself. So the security context is getting attached just like we said in here. And then that's basically it. You can keep going for all the other deployments and you will see that all the resource groups are getting set as well. Now this makes it super easy for me to change the resource limits for any of the resources, like the add service we have in here. Let's say we want to change the resource specification for this deployment, right? So let's say I just go to my add service and I change the label to resource group A. Something you can do, okay? And I just build again. Now let's take a look at what that does. Now the resource limit that's attached to the deployment should be resource group A. And if we look at the resources section, we can see that we have an updated resources list just by changing a label. Now you can begin to imagine the amount of flexibility that this functionality can introduce in your customized workflow. Okay, so let's do an apply and just confirm that our application works. So now we're gonna do a kubectl apply, okay, like before, and throw in a dot there, and that should apply all our manifest files. Now let's get a pod and the service resources just to confirm that everything's running. Okay, we have everything running fine and good. Now let's go to the port again. We need to forward port 31244. So kubectl port forward service front end external, and we're port forwarding ports 31244 to port 80 in the container. So now back on our browser, we go to port 31244. We should have our application running just like before. We can select items on our cart. We can add quantity, add to cart. We can place our order, and everything works just as before. Okay, so our application works exactly like we expect it to. Okay, awesome. So that's one way you can clean up some of the manifest files in a customized workflow and make things much more easier to work with. In the long run, now same thing we've done for dev, prod as well. Just very simple. We can decide to turn off components that we don't want or enable features as we want to as well. So just take this as a sample of one way you can begin to improve your customized workflows. But there's a lot you can do. I can think of so many ways that we can continually improve these manifest files and make them super easier to work with. Just think about the flexibility that Kustomize gives you with workflows such as this. So that's basically it for the second day 2 or version workflow. And in the next video, we're just going to look at the third way in which we can structure our customization file. And that's usually for super large applications. For most microservices out there, it should be sufficient enough to be able to manage your customization workflow. So thank you for watching this video. If you're enjoying this video, don't forget to hit the like and subscribe button so you don't miss future contents like this. Thank you.